This is a picture of a nuclear reactor. We've seen this diagram before. Especially we've seen the right part of the diagram. That is, you take the water and you put in some kind of boiler and produces steam. Steam runs the turbine. Turbine runs the generator that produces electricity. The steam is being condensed through the condenser and turned into water, and the cycle repeats itself. In the coal power plant, the fuel that turns the water to steam inside the boiler is coal. In the gas power plant is natural gas. In the nuclear power plant, basically the heat which is required to turn the water into steam comes from the fission of the uranium. That's the only difference between the nuclear reactor and the coal reactor, is a way to produce the heat which turns the water to steam. This table shows the electricity generation by different countries. United States has the largest number of the nuclear reactor in operation. It has 144 nuclear reactors, but by 2010. But as the time goes on, some of the nuclear reactors are going to be retired. So the numbers are expected to, at least for now, to decrease. As a whole, the nuclear reactor produces 101 gigawatt of electricity. That means it's roughly about 1 gigawatt per nuclear power plant. That's the number you might want to remember. Nuclear power plant produces 1 gigawatt, and compared to the coal power plant, which is about 300 to 500 megawatt. So the rule of thumb, one nuclear power plant is giving the same power as two coal power plants. So 20% of our electricity, it comes from the nuclear reactor. France does not have as many nuclear reactors, but it's much a smaller country, and so 75% of their electricity comes from the nuclear. They're highly dependent on the nuclear power. And you can move down the list, and you can see that a country like China, it doesn't have only 2% of their power come from electricity, but this number is expected to grow because they depend largely to the nuclear plant as the resources for the fossil fuel is rather small. This is another presentation of the nuclear plants around the world. You can see a lot of plants in the Europe. It's very, very concentrated. The eastern part of the United States, there are some in the western part, a few in California. The other places are Japan, as you can see, and some in Russia, but not quite that many. And there is one spot here, which is a nuclear plant in Iran that had been under a lot of political discussion these last few years. Depending on what kind of coolant and what kind of moderator they use and what pressure, the nuclear reactors can be divided into different forms, different classification. We have a high pressure, low pressure, or let's say graphite power plants. These are the commercial nuclear plants in the world as of 2008. So you can see that there's a pressurized water reactor, or boiling water reactor, hot water reactor, etc., and the countries that they use them, and the number of the nuclear reactor that they're using there. So that would be basically a short summary of all the nuclear reactors which are operating in the world and the type they're operating. The discussion, what is the advantage of one over the other, is outside the scope of this class, but I suggest that you read the book and you read on your own on what the differences between different type of nuclear plants are. One type of power plant that they have taken some attention is a fast breeder reactor. Fast breeder reactors are using the non-fissionable uranium-238, as you remember we call them fertile, to the fissionable plutonium-239, which is fissile. So you can use either one, uranium-235, and convert it to plutonium-239, or just use the plutonium-239, and this will add extra energy. They're used mainly in the Europe and Russia, and because the amount of energy is much higher than the regular power plants, then the water is not enough to cool it, so they use the sodium as a coolant for this type of reactor. The disadvantage of this reactor is, of course, is that sodium is highly explosive, so you need to extra careful as far as the safety is concerned. And then the plutonium that's used here is also the bomb grade quality, and if it falls in the wrong hand, can be constituted basically a dangerous proliferation of the nuclear energy. What is plutonium? In the few slides past, we told you that uranium is the heavier of all elements, natural elements. Plutonium-239 is heavier than the uranium, which is 238, but it has a very short half-life, so it has to be manufactured, and it will be manufactured in the laboratory. So that's one of the problems with the nuclear reactor, that the fuel can be used, for proliferation to plutonium, which is a very good nuclear weapon fuel. So the reactor goes something like this. A neutron hits the uranium-238. It turns into the neptunium-239, and neptunium-239, one of the neutrons will turn into the proton and become plutonium-239. And the plutonium-239 then splits and produces other products, and a lot more energy is being released. A type of nuclear power plant that has taken some attention lately is a pebble bed reactor. In this case, the reactor core is made of thousands of little pebbles. Each of them consists of several thousand smaller pebbles, which are called microsphere, the size of the small sand grain, about less than a millimeter in diameter. And each of these microspheres is coated with several layers of graphite that act as moderator, and silicon carbon, which is covering the outer shell. After the fission in each of these microspheres completed, the coating then can act as a casket, isolating and retaining the radiation long enough for the uranium to decay to reasonably safe limit. So the shutdown of this can be done relatively safely. The advantage of this is, of course, is modular, is small, it can be flexible for design, and to design in different sizes. That is a direction that some power companies, they're going instead of the conventional nuclear reactor. So they have a tiny nuclear reaction in each of these microsphere, and after one nuclear reaction is completed, then the next one adjacent microsphere starts. There is no commercial pebble bed reactor of this kind operating yet. China is doing some experimental pebble bed reactor, and South Africa is planning to construct a commercial plant, but nothing yet.